Hello everyone. Today I'll discuss exercises which I gave you in my first lecture of matrices. If you have not seen yet, the link is given in the description. Do check. Before I start, here are those two important codes which you should never forget. Now let's come to the topic. Let's discuss the exercises. I'm going to discuss these three exercises together. What is order of a row matrix, column matrix and a square matrix? As you all know, order of a matrix is number of rows by number of columns. For a row matrix, number of rows equals to 1 and number of columns equals to n. Therefore, order of a row matrix is 1 by n. And for a column matrix, number of rows equals to n and number of columns equals to 1. Therefore, order of a column matrix is n by 1. And for a square matrix, number of rows equals to number of columns equals to n. Therefore, order of a square matrix is n by n. Let's go to the next exercise. The next exercise was give example of each type of matrices discussed in the session. So in the session, we discussed 9 types of matrices. Let's give example of each type one by one. The first type was a row matrix. Row matrix is what? A matrix with single row and n number of columns. So to give example of a row matrix, we will construct a matrix of order 1 by n. Suppose n is equals to 3. So I am giving here example of a row matrix with 3 columns -1, 0, 7. Let's move to the second type. The second type was column matrix. For column matrix, we should give example of n by 1 matrix. Suppose I give example of 3 by 1 matrix. That's a column matrix with 3 rows, 2, 1, 4. So here is example of a column matrix. The third type of matrix which we learned is a square matrix. A square matrix has order 3 by 3, 2 by 2, 4 by 4, in general n by n. So suppose I give example of a square matrix of order 2. So here is your example of a square matrix of order 2 by 2. The next type was identity matrix. Identity matrix was a square matrix which is having 1 on the diagonal and zeros on the non-diagonal. So suppose I give example of identity matrix of order 3, which is known as I3. 1 0 0 0 1 0 0 0 1. The next type was null matrix. Null matrix is nothing but a matrix with all elements 0. To produce example of that, what you have to do, you have to take any order matrix. Suppose I take here 2 by 3 matrix, and then you'll have to set all elements 0. The next step which we learnt is diagonal matrix. For diagonal matrix, what you have to do, you have to take a square matrix. Suppose I take a square matrix of order 3, and what you need to do, you have to put any number on the diagonal and zeros on the rest of the places. Any number, suppose I put 2, -1, 0, and rest of the places 0. So you can put rest of the places 0 like this. So to give example of a scalar matrix, I'm going to take a square matrix of order 3. in which I'm going to set diagonal entries same. Suppose I'm taking, let's say, 2 on the diagonal, and I'm going to set non-diagonal entries 0. So here you get example of a scalar matrix. This is also written as 2i3. The next type which we learned is upper triangular matrix. Upper triangular matrix is what? A matrix in which elements below diagonal is 0. So if you see this one, here is your diagonal, and elements below diagonal you can see it's 0. So actually speaking, this is also an example of an upper triangular matrix. And lower triangular matrix is what? Lower triangular matrix is what? Elements above diagonal is 0. So if you see this, elements above diagonal is 0. So this is also an example of upper triangular matrix. So what we can do, we can take a fresh example instead of having same example for each type. Let us have one example for upper triangular and one example for lower triangular. Suppose I construct a upper triangular matrix of order 3. To construct upper triangular matrix, what you have to do? You have to take elements below diagonal 0. So I am going to take elements below diagonal 0. And what about rest of the places? Rest of the places you can fill anything. So suppose I fill -1, 4, 0, 3, 0, 2. So here is an example of upper triangular matrix. The next example which we want is lower triangular. For lower triangular, elements above diagonal has to be 0. So let's set elements above diagonal 0. So this 3 elements has to be 0. And what about rest of the places? Rest of the places you can fill anything. So suppose I fill here 1, -2, 3, 0, 1, 4. So here is an example of lower triangular matrix. And all 9 types are done. Let's move to the next exercise. Give example of a non-square matrix. We all know what is a square matrix. Square matrix is what? A matrix which is having equal number of rows and columns. So non-square matrix is nothing but which is having different number of rows and columns. Both numbers m into n which we say are not equal. Okay. So here is one example of a non-square matrix. You can see the matrix which you have on the screen, that is of order 2 by 3. 2 is not equals to 3. So this is an example of a non-square matrix. Let's move to the next exercise. Here is our next exercise. In a matrix of order 5 by 7, number of rows equals to. So whenever we say matrix of order m by n, m gives you number of rows, n gives you number of columns. I have in place of m 5. So 5 is nothing but number of rows, and 7 is nothing but the number of columns. So the answer becomes 5 number of rows and 7 number of columns. And next is number of elements. Number of element is what? So you have to multiply those two numbers. 5 into 7 is 35. So number of element in that matrix is 35. Let's move to the next exercise. Exercise number 7. What are the possible orders of a matrix with 12 elements? To get possible orders, what we need to think? We need to think what are the positive factors of 12. Positive integer factors of 12. So if we start from 1, 1 and 12 are the positive factors of 12. The second positive factors we can take as 2 and 6. 2 into 6 is 12. We can even have 3 and 4. 3 fours are 12. So these are the positive factors of 12. So what will be the possible orders? The possible orders are 1 by 12, 2 by 6, 3 by 4, and also 12 by 1, 6 by 2, 4 by 3. Since we know 1 by 12 is not same as 12 by 1, both the matrices are two different matrices. Let's move to the next exercise. Exercise number 8. Is it possible to have a square matrix with 18 elements? Justify. So the answer is no. And let's talk about the justification part. We know that for a square matrix, order is equals to n by n. Order equals to n by n. If order equals to n by n, number of elements in a square matrix will equals to n square. We have number of elements equals to 18. So can we have n square equals to 18 for any positive integer? We cannot have. So that's why it is not possible to have square matrix with 18 elements. Let's move to problem number 9. Here is your problem number 9. Let's discuss that. Here is your problem number 9. We have to find out these all elements which are listed below. We all know Aij. Aij is what? Element present in ith row and jth column, where I represent the row number and j represent the column number. The first is A12. A12 is what? Element present in first row and second column. Here is your first row and here is your second column. So here is that element. So the answer is 7. Next is A31. A31 is element present in third row first column. Here is your third row. Here is your first column. So the answer is -1. Next is A23. A23 is element present in second row third column. Here is your second row and here is your third column. Here is your element. So the answer is 1. Next is A14. A14 is element present in first row fourth column. First row is here and fourth column is here. So the answer is 6. Next is A31. A31 is element present in third row first column. That is -1. A24 is element present in second row fourth column. Second row fourth column, you all can see the value is 5. Element is 5. Next is A13. A13 is first row third column element. First row third column element is 4. So the answer is 4. Let's move to the next. Here is your problem number 10. I feel this is very important problem. Let's discuss this problem number 10. So here is your problem number 10. What we have in problem number 10, we have a matrix A for which we have to answer this 9 yes or no type question along with justification. Let's see what question number 1. Question number 1 is A a row matrix? So what is a row matrix, by the way? A matrix in which there is a single row and n number of columns. That means there is a one row and there can be n number of columns. N number of columns means we can have one column or two column or three column. We can have any number of column, but there has to be only one row. In our case, we have one row and we have one column. So definition satisfied. So A is a row matrix. What's question number 2? Is A column matrix? What is a column matrix? A matrix in which there is n number of rows and one column, single column. N number of rows means there can be one row or two row or three row or any number of rows, but there has to be only one column. And in our case, there is a one row and there is a one column. So again, definition satisfied. So A is a column matrix. What about question number 3? Your question number 3 is A square matrix? What is a square matrix? A matrix in which number of rows equals to number of columns. In our case, number of rows equals to 1 and number of columns equals to 1. So number of rows equals to number of columns. So yes, A is a square matrix. So definition satisfied. So A is a square matrix. What is your question number 4? Is A an identity matrix? What is an identity matrix? A square matrix in which diagonal entries are 1 and non-diagonal entries are 0. What we have in our case? We have a square matrix which is having only one entry, that is, we can say A11. A11 is nothing but a diagonal entry, and diagonal entry according to the definition has to be 1. So that is 1. So again, definition satisfied. So A is an identity matrix. There is no non-diagonal entry, so we need not worry about non-diagonal entries. So yes, A is an identity matrix. Next question. Is a null matrix? So what is a null matrix? A matrix in which all elements are 0. But in our case, we have a non-zero element. Your A is having a non-zero element. So A is not a null matrix. So answer is no. Next question. Is A diagonal matrix? What is a diagonal matrix? A square matrix in which non-diagonal entries are 0. Okay? A square matrix in which non-diagonal entries are 0. What about diagonal entries? Diagonal entries can be anything. And what we have in our case? In our case, we have a square matrix in which diagonal entry is 1. There are no non-diagonal entries, so we need not worry about zeros. So we have a diagonal matrix. A is nothing but a diagonal matrix. So answer is yes. What next? Is A scalar matrix? What was a scalar matrix? Scalar matrix is nothing but a square matrix in which diagonal entries are same and non-diagonal entries are 0. We don't have non-diagonal entries. We need not worry about 0. We have only one diagonal entry and that is 1. So again, definition satisfied. So that's a scalar matrix. Is A upper triangular matrix? What was upper triangular matrix? A matrix in which elements below diagonal are 0. So if we compare that definition with our case, in our case, we have just one, that's a diagonal entry. There is nothing below diagonal. So we need not worry about 0 below diagonal. So yes, definition satisfied. Your A is upper triangular matrix. Is A lower triangular matrix? What was the definition of lower triangular matrix? For a lower triangular matrix, elements above diagonal has to be 0. But we don't have in our case any element above diagonal. So we need not worry about zeros. So our definition satisfied over here. So yes, the given matrix A is a lower triangular matrix. Here we are done. Thanks for watching, and don't forget to like if you like the video, comment, share and subscribe to my channel if you haven't subscribed yet. And if you have any queries, you can mail me your queries or you can ask in the comment section. Thank you so much.